up where we left off yesterday. I know that we didn't finish 10.1, so let's do that. We left off on example 1. I was interested in finding out the likelihood of students going to college based on if they were in calc or if they were in pre-calc. So if you guys remember, we left off putting everything into our calculator. Um, and so we had gone through, checked all of our conditions. I had way more in the board. I will finish these notes up and scan them in today, but you guys should have had all of this done anyways. So what we ended up doing was the two proportion z-test, and we came up with a p-value of 0.201. So what the heck does that mean? You guys are still going to conclude in the same way that you would have before. If there is no alpha given, you're going to still use alpha as 0.05. So because our p-value, 0.201, is greater than alpha, we are going to, what are we going to do? We're greater than. Remember, if p is low, we reject the hoe. This is greater, so we fail to reject. Because our p-value is greater than alpha, we will fail to reject the null, and we do not have significant evidence to conclude. Now you're going to conclude the ha in context. So we do not have significant evidence to conclude that. Now on our notes yesterday, we did the opposite of what I have here. You guys chose P1 and P2 differently than I have currently. So your guys' will be the reverse. I'm going to keep mine in order as far as what I have on my paper. So people that were absent, if they follow it, um, they would have exactly what I have. So I chose the people in pre-calc to be P1. So in my notes, P1 was the true proportion of pre-calc students who plan to go to college, and P2 were the true proportion of students in calc who tend to go to college. So when I do my subtraction, I would be saying that I do not conclude that the difference in proportions, and that would be pre-calc to calc, are not greater than 0. Okay, you guys have the reverse. You guys chose the reverse of what I have. So you would have that calc to pre-calc are not greater than, or you had less than or equal to 0. You guys had that. Okay. So as we move forward, the question at the bottom is, was this an observational study or an experiment? There was no treatment that was placed. These people were simply surveyed and asked if they were going to college. So because there was no treatment placed, the answer is this is not an experiment. So can the results from the above example allow us to make claims about cause and effect? No. You can only do cause and effect when you have an experiment. Okay, so this was an observational study slash survey of students that were already in those classes. Okay, what is the scope of the inference here? The scope of inference is still going to be the senior math students in Michigan. Okay, so let's go ahead and do the second example, and then you guys can go ahead and work on homework A55. And so here we go. In an effort to reduce healthcare costs, General Motors sponsored a study to help the employees stop smoking. In the study, half of the subjects were randomly assigned to receive up to $750 for quitting smoking for a year, while the other half were simply encouraged to use traditional methods to stop smoking. None of the 878 volunteers knew that there was a financial incentive when they signed up. At the end of 1 year, 15% of those with the financial rewards had quit smoking, while only 5% in the traditional group had quit smoking. Do the results of the study give convincing evidence that a financial incentive helps people quit smoking? Again, key words, guys, convincing evidence. That tells us that we're going to do a significance test, okay? So here we go. The very first thing we need to do is, what type of a test is this? Well, we have two proportions. We have those that were given the incentive of money and those that did the traditional. Does it make sense to subtract them? No. So this isn't matched pairs. This is a 2 proportion Z significance test. That's the name of the test. What do we need to do next? Define our parameters. So let's call P1 the true proportion of employees who quit smoking to get the financial rewards, the money, okay? And we'll call the second one the true proportion who quit smoking traditionally. Okay? Try to zoom out. I was trying to zoom more in so you guys could get most of the paper on there, but it's a little bit hard. Let me see if I can put this up a little bit maybe. Oh, nope. Okay, we'll just keep trucking this way. Okay, so after we have defined our parameters, we need to come up with our ho and our ha. Okay, so the ho and the ha. The ho and the ha. Well, if there's truly no difference between the traditional and the money incentive, then we would expect to subtract those and get 0, right? And what we would like to say is that we think that money is actually getting us better results than the traditional way, so greater than 0. Okay. Let's go ahead and write down what alpha is. They haven't given us one, so we are going to default to 0.05. Let's go ahead and write down what p hat sub 1 is. That was the employees who quit smoking for the money, and they gave us that up here in the problem, 15% with financial rewards. So that was 0.15. And p hat sub 2 was those who quit with the traditional way, and that was right here, only 5% in the traditional group, so that was 0.05. And I lost my train of thought. Okay, so next let's choose our conditions. Okay, we have money and we have traditional. Okay, so random. Did they randomly select anything? Well, they randomly assigned, in the study, half of the subjects were randomly assigned, okay, to receive up to $750. So they didn't take a sample. It is random, but it's not necessarily a random sample. They took a group of people and randomly assigned. So we're going to have to be careful with that. So randomly assigned, both of these. Okay, and let's talk normal. So for the first group, if we do n sub 1, p sub 1, you get 66. If you're not sure how I did that, there was 15%. Okay, and half of the subjects were randomly assigned. So the main sample was 878. Half of the subjects went to each one. So half of that times 0.15 is 66. And what is left over, your failures, 373. And if we do the same thing over here, you should get 22. And the only difference here is that you're still using half of the 878, except for this time we are talking about 5% instead of the 15%. Okay. Independent. This is the General Motors Company. That's a large company, right? So is it safe to assume, and maybe I should take the half of 878 because 439, is 439 less than or equal to a tenth of a large company? Yeah. And that works for both of those because they did half and half. Okay. Okay, so like I told you guys the other day, let's go ahead and put this in our calculator. If you don't remember how to put this in your calculator, you're going to go to Stat. Oh, this is really hard to see on here. Over to Test. We're doing a 2 proportion z-test. It's literally what it's called in the calculator, 2 proportion z-test, okay? We want to know the number of successes, the number of the sample. Well, the number of the successes is this thing right here that you guys already found. So 66 said yes out of 439. And 22 said yes, right there, out of 439. Okay, and then we come down here, and again, we're not sure how to do this. So if you guys look back up here at your null, to put this in your calculator, this is the same thing as solving. If you add this to the other side, you get that p sub 1 is greater than p sub 2. Okay, now when you look at your calculator, it says p sub 1 colon, and then it has the options. Well, p sub 1 we decided needed to be greater than p sub 2. So p sub 1 is greater than p sub 2. That's the option all the way on the end. Okay? And then calculate. Remember, guys, I want you to write all of this down. Okay? I'm going to write it down here in just a second. This right here is your p-value. Notice, guys, you can't have a p-value that's 3.8. So look over here on the side. There's really times 10 to the negative 7. Okay, that is a ridiculously small number. 7 decimal places to the left is where that should be. So I'm going to write down everything that I get in my calculator. I already have my p-hats. P combined, guys, that works a little bit different when you have your decimals. P combined comes out of your calculator and it gives you 0.1. You'll get that down here. It's the last p-hat that it gives you, if you can see that right there. It works a little bit differently when it's not fractions. So you would have to convert those back. You can't just add these is what I'm getting at. Okay, so this is our p-value. Let's go ahead and assume that's pretty much just 0, right? So p-value is approximately 0. So how are we going to conclude? Well, because our p-value is less than alpha, we reject, oops, I forgot to put my value in there. It's 0. We reject the null, because P is low, reject the HO, and do have significant evidence to conclude, try to get it all in there, that there is a difference in the proportions of people or employees, that's a better word, who quit because of money. Done. Okay, again, I know it's hard to see this, guys. I will scan these in so that you have a clearer copy. Okay, so let's follow up. Was this an observational study or an experiment? Yes, because they actually gave a treatment, right? What was the treatment? You guys talking about it? The treatment was whether they got the money incentive or not. Okay, so can the results from this example allow us to make claims about cause and effect? Yes. Okay. What is the scope of inference? Well, we have a problem with our random condition. They randomly assigned people, meaning we had volunteers. So this isn't necessarily a sample that's representative of the population of General Motors. So we actually have a problem with scope of inference, okay? It wasn't a random sample. And therefore, our conclusion can only hold for the people that were in the experiment. Which hopefully makes sense. You had a bunch of volunteers, so you have undercoverage of some subcategories there. So you can't necessarily say that that works for all of them, okay? So your homework, guys, or in class, because you have time, is A55. Realize that on Friday, I am going to collect A53, A54, A55, and the notes from 10.1, difference in proportions confidence interval, that I signed off, the ones that I initialed in class on Wednesday. So be prepared to turn all of those things in. We will go over questions when I get back, so have those ready, and I will